Hello, hi everyone, good morning, welcome to the channel. This is the video number 2, or this is the second video in Kubernetes playlist I am putting in. And in this video we are going to talk about Kubernetes architecture. We will be explaining bit and pieces of Kubernetes architecture. And before we move to Kubernetes architectures, let's recap some of the important point in Kubernetes. Something like Kubernetes is an open source, as you know. If you have seen my previous video, you must be aware. So Kubernetes is open source and entire source code is available on GitHub. Kubernetes is written in Go. Almost 80% of Kubernetes programming has been done in Golang. Okay, and as you are aware, the latest version of Kubernetes is version v1.32. Earlier, the previous version was version 1.31. And as you are aware, Kubernetes is a tool or platform for deployment, for deploying, scaling, and managing and management of containerized application. So Kubernetes is an orchestration platform that helps us in managing the containerized application, guys. Now in today's session we will be talking in detail about Kubernetes architecture. So let's draw a diagram and try to understand what are the different type of components we have in a Kubernetes cluster. So if we talk about components in Kubernetes cluster, so we have two major component. One is called as control plane, that is called as control plane, and control plane consists of sub components. And what are these components? Are called as, the first sub component is called as kube-apiserver. Second is called as kube-scheduler. Then third is etcd, and fourth is your controllers. Okay, fourth is your controllers. There are two type of controllers. One is called as kube controller, and then another is called as cloud controller. Okay, cloud controller. If we talk about in detail, okay, we will talk about in detail with the kube controller and cloud controller as well. And as I told you, in Kubernetes we have another component that is called as worker node. So worker node consists of another sub components. What are the sub components? The three major sub component. One is called as kubelet, another is called as kube-proxy, and the last one is called as container runtime. Okay, container runtime, that is container D. Okay, so let's draw a diagram and help understand how a Kubernetes cluster, what are the important components of Kubernetes cluster, and what are the function of each of the components we will discuss here. Okay, so this is going to be our Kubernetes cluster enclosed inside a network. We can call it this will be a VPC. The name of the VPC, we can give VPC my 001, and this VPC can have your CIDR. Okay, now this, inside this we will have a control plane. And this control plane is sometimes called as management node. So we can call it control plane as well as management node as well. Now we have worker nodes where the containerized application will be running. So these are called as worker nodes. So we can have multiple worker nodes. We can have up to 5,000 worker nodes. So this is worker node 2. Okay. Now control plane consists of various subcomponent, as I told you. And the very first component is called as kube-apiserver. Second is called as kube-scheduler. The third is is, as you are aware, etcd. Etcd is a database. Okay, it's a key value pair database. And then we have controllers, guys. So controllers, these are very important, and they have very important functioning in Kubernetes. And we have kube controller, and then we have something called as cloud controller. So these controllers are inbuilt controllers. Controllers are also basically of two type. If we see on high level, we have inbuilt controllers and something called custom controllers as well. Now every worker node consists of container D, which is basically the container runtime. So container runtime, earlier container runtime was Docker, but Docker has been removed, and container D as a container runtime has been used. After this, we will have, there is something called as kube-proxy. Okay, and then we have something called kubelet. So this will be same across all the worker nodes. So if you have 10 worker nodes, you will witness the same. Every worker node will have container runtime, kube-proxy, and kubelet. So all these components are very important for the proper functioning of the cluster. And now this is the cluster, and how you basically connect to a cluster. So you will be here, you will be working with your system. You will have a system, and you will be downloading something called as kubectl, or we call it kube-ctl. So we will be downloading a command line tool, kube-ctl, or in simple words we can say like this: kube-ctl is a command line tool. Kube-ctl is a command line tool which is used to connect / communicate with the cluster, with the Kubernetes cluster. Okay, now, so kubectl can be installed on Windows or Mac as well. So kubectl can be installed on Mac as well as Windows as well as Linux. So whatever system you have, if you have Windows laptop, or if you have Windows OS, if you are working with Linux, if you are working with Mac, no problem, you can download and install kubectl command line tool, and with the help of this kubectl command line tool, you can connect to this Kubernetes cluster. Now we will tell you exactly what happened is basically we will tell you all the components working one by one. So let's go. And this is how a user basically connect to a Kubernetes cluster. So the user basically connects to a Kubernetes cluster like this. All the incoming requests will land on this kube-apiserver. So all the request or event, or we call it request, we can call it request or event. This is pretty much darker. Yeah. So all the requests and events, if you are making all the requests and all your events will go and land on kube-apiserver. Okay, so we'll talk about kube-apiserver, kube-scheduler, etcd, controllers, kubelet, kube-proxy, all the components one by one. Let's go here. But this is how your typical cluster look like. So this is the Kubernetes cluster with one control plane and two worker node, guys. Okay, now let's take a look to working of all the components. So first we will be talking about the first is called as kube-apiserver. So kube-apiserver, what is kube-apiserver? So kube-apiserver act as landing point Okay, second is all the incoming requests will be intercepted by all the incoming requests will be intercepted by your kube API server. So all the incoming requests, whenever you fire a request, your request will be intercepted by kube API server, and kube API server performs kube API server perform authentication, authorization, and admission control. So in simple word, kube API server is going to cross check, is going to verify that you are correct person or not. Do you have you are the correct person or not who's sending the request. It will verify whether you have you have permission to run that command or not. And then in admission control there are two things will happen. So admission control, there is something called as admission controller, and admission control basically invoke two type of checks. It further invokes two type of checks, and these two checks are called as mutating webhook. There is something called as mutating webhook, and then another one is called as your validating webhook. Okay, so if you are making a request to a Kubernetes cluster, okay, if you are making a request to Kubernetes cluster, your request will land on kube API server. Kube API server will perform authentication, authorization, and admission control. If everything is okay, then kube API server will forward your request either to scheduler, or kube API server can talk to etcd and will give you the answer. So it depends upon what kind of request you are making. So I will give an example here. So kubectl get node. So this is a command. So basically this is kubectl get node. It means we are making a read operation. So if you are trying to read any information from the cluster, what will happen is kube API server will perform authentication, authorization, and admission control, and then it will pass the control. It will go and check to the etcd, and from here it will read the information, and it will give the response back. Now in an event, if you are creating something, let's suppose there is a difference between read and write operation. There's a difference between get and there's a difference between creating and reading. So kubectl run mypod -name -image equals to nginx. So in case if I am making this particular command, if I am running this particular command, what this command is doing, it is asking to create some resource on the Kubernetes cluster. So the behavior of API server will differ in case if we execute this command and in this command. So whenever you are doing a read operation, the kube API server will go and read the information from etcd and will give it back to the user. And in case if you are asking a cluster to create some resource for you, in that situation kube API server will forward the request to kube-scheduler. Now kube-scheduler is the one which is responsible for scheduling the user workload. So if we talk about kube-scheduler, okay, so kube-scheduler, if we talk about kube-scheduler is basically a workload scheduling function. We call it workload scheduling workload scheduling function. So kube-scheduler is responsible, in very simple terms, kube-scheduler is responsible for scheduling pods to the nodes. And how kube-scheduler does it? So kube-scheduler checks the request. So we will keep it this much here for kube-scheduler, because if we go in detail we need more information. We will be videos coming where we will be discussing every particular component in detail. Okay, but as of now, what you can understand, so kube-scheduler is basically responsible for scheduling the user workload on worker nodes. So on this particular worker nodes we will be scheduling. Now kube-scheduler will decide which node he has to schedule the pods. So he has to schedule the pod on worker node 1, or he has to schedule the pods on worker node 2. All these information will be processed by kube-scheduler. But kube-scheduler, there's a component called as kubelet. So kubelet is also called as primary node agent. Kubelet running on each worker node, this is called as primary node agent. So if we talk about kubelet, let's go here. So if we talk about kubelet, guys, so kubelet is called as primary node agent. And what kubelet is responsible for? So kubelet keep updating the status of worker node to the scheduler via API server. So kubelet running on these worker nodes is responsible. This kubelet keeps updating the status of worker node to the scheduler via API server. So scheduler exactly know which particular pod which particular node is free, and scheduler can take decision. Okay, scheduler can take decision accordingly. Scheduler will assign the pod to particular node. Okay, so scheduler will pass the information to the kubelet to create a pod on this particular node. So scheduler works both the ways. So kubelet is responsible for updating what is happening on the node. So kubelet is a primary node agent. And kubelet keeps updating the status of worker node. Okay, so once the scheduler basically decide, okay, so scheduler is responsible for scheduling the pods to the worker nodes. We can keep like this, to the worker nodes. Kubelets keep updating the status of worker node to kube-scheduler. Kube-scheduler instruct kubelet of a particular node to kubelet to create pod on the node. So guys, kubelet has two responsibilities. So kubelet keep updating the status of worker node. Along that, kubelet is responsible for creating, deleting, updating, and scaling of pods on worker node, So scheduler is the one who only decide, and once he decide, he instruct the kubelet to create the pod, and kubelet running on the worker node manages the container lifecycle. So kubelet running on the worker node manages the container life cycle. Okay, so this is what with respect to kube scheduler. Now we will talk about something called as etcd. Let's talk about something called as etcd, what etcd is doing. So etcd is nothing. Etcd is a key value pair database. It's a key value pair database. It is a single source of truth. And the state of the cluster is preserved. Preserved in the etcd database. So state of the cluster will be preserved in the etcd database, guys. Okay, so etcd act as a storage which makes sure that current state of the cluster should be stored over here. Now after this we will talk about controllers, guys. After that we will talk about controllers. So controllers, as I told you, so we have controllers. We have two type of controllers. One is cloud controller, and one is basically cloud controller, and then we have kube controller. So let's talk about kube controller, and then we have something called as cloud controller. So this is kube controller, and then we have something called as cloud controller. So in Kubernetes there are multiple in Kubernetes there are multiple controllers. Example, there are something called as node controllers. There is something called as replication controller. Then we have something called as endpoint controller, and then we have something called as service account controller. Okay, service account controller. So these controllers, these inbuilt controllers, so these are basically inbuilt controller. These inbuilt controllers keeps your system, keep the cluster into desired state, and each controllers keep watching each controllers keep watching the respective resource. So for example, if there is something called as node controller. So node controller, what is the responsibility of node controller? So node controller is responsible, if we talk about a node controller, so node controller is responsible for monitoring all the worker nodes. In case if any worker node goes down, we need this node controller goes down, this node controller will inform us. Inform us. So these controllers are nothing. Controllers are basically called as observers. We can understand like this: controllers are observers. I can give you a practical example. So everyone must have appeared in exam, and in exam we have exam controllers who basically watches the status of the exam, who take care of the exam, make sure exam happens correctly. In the similar way, Kubernetes is a big ecosystem, and to watch everything working perfectly, to keep everything working perfectly, we need to have some observers or controllers. These controllers keeps on watching certain resources and respond in case if the desired state is not matching, guys. Okay, and cloud controller will only be applicable if you are creating your Kubernetes cluster on AWS or GCP or AKS. In that case, so in cloud controller also we have something called as node controller, which typically does the same thing. So we have node controller from the perspective of cloud controllers, and we have node controller from the perspective of kube controllers. It means the same node is being watched by Kubernetes, as well as the same node will be watched by cloud provider as well. Okay, now so we have spoken about kube-apiserver, we have spoken about kube-scheduler, we have spoken about controllers and etcd and kubelet. Now we have something called as kube-proxy and container runtime. So worker node, when it comes to worker node has three major component. One is your kubelet. So kubelet, as I told you, it is also known as primary node agent, and it keeps updating the status to kube-scheduler, and kubelet only manages the container lifecycle on the worker node. And then we have something called kube-proxy. So kube-proxy is a very, very important component, and kube-proxy is responsible for networking. It is responsible for networking within the cluster. It is responsible for networking within the cluster. Okay, cluster. It provide unique IP address to the pods. It provide unique IP address to the pod. Unique IP address to the pods. And it controls the flow of traffic. Kube-proxy internally uses a Linux kernel feature that is called IP tables. Linux kernel feature that is called as IP tables. So with the help of IP tables, kube-proxy control the flow of traffic. The last goes here is container runtime, guys. Container runtime. So container runtime is basically the software which basically help us to create container on the worker node. Earlier, if we talk about something, so earlier Docker was the preferred container runtime, preferred runtime, but now Kubernetes uses container D for container runtime, for container runtime. Okay, so Docker was, to be very precise, Docker was removed as a standard container runtime from the version 1.20 plus. Okay, so from 1.20 of Kubernetes, the Docker was dropped, and container D was preferred container runtime, guys. So this is what with respect to Kubernetes architecture. So this Kubernetes architecture consists of two major components. One is control plane and another is called kube-apiserver. Kube-apiserver, scheduler, etcd, and then controller here. And controllers are of two types. One is kube controller, and then that is basically kube controller means Kubernetes controller, and then we have something called as cloud controller. Then we, from the worker node, we have kubelet, kube-proxy, and container runtime. So that's it for the day, guys. Thank you. If you have any questions, please do ask in the comment section. We will cover each of these components in detail in separate video. If you have any questions with respect to Kubernetes architecture, kindly let me know. Drop your message in the comment box, and you can share the video and subscribe the channel. Help me support me in growing this channel, and share this video with your IT circle, with your IT friends, and anybody who wants to learn Kubernetes. This was the day 2. This was the second video in the playlist. More is about to come. Thank you.